Zeros of polynomial functions. In this section, we want to learn how to find the zeros of a polynomial function f of x. So in other words, we needed to solve this function f of x, this equation f of x equals 0, find x values to make this polynomial function to be 0. So here is some theorems we need to know. That the first one is called the fundamental theorem of algebra. It says if f(x) is a polynomial function, with degree n greater than or equal to 1, then f(x) has at least one zero in the complex number system. Okay, so we know that the real number is a part of the complex number. So the complex number is a much larger set for numbers. And the next theorem, which is called the linear factorization theorem, that is useful for our today's topic. Linear factorization theorem. So suppose if f is a polynomial function with degree n, which is greater than or equal to 1, then f of x can be written as an times x minus c1, x minus c2, and x minus cn. So in other words, in the complex number system, you can always factorize this polynomial function f of x as this form. So here, an is the coefficient for the highest power term, okay? And the c1, c2, and the cn are all zeros, because if you plug in c1, plug in c2, or plug in cn, it will also make the function to be 0, right? So c1, c2, cn are all zeros, and these are also the complex numbers, where ci is from 1 to n are complex numbers. Okay, keep in mind, a real number is also a complex number, just with the imaginary part to be 0. Okay, so from this theorem, we want to look at some remark. This theorem tells you that the nth degree polynomial function has n zeros. Okay, and 2, you can find that this 2 is note that a real number is also a complex number. That means a real 0 is also a complex 0, right? Okay, so now let's look at one example. This is if f of x equals x cubed plus 4x. Okay, so we want to find the zeros, right? So from this theorem, if you can factorize it, if you can find this factorization, and then you can find the zeros automatically, right? So let's try to factorize it. This is x, so this degree is 3. So you have C1, C2, and C3, right? So we factorize it. We take x out. This is a common factor, x squared plus 4. So here we want to use this result. A minus bi times a plus bi is equal to a squared plus b squared. We want to use this result when we study the complex numbers. So it can be written as, so this is 2 squared, so it becomes x minus 2i times x plus 2i. So we can always factorize to a linear term. This is called the linear factorization. Each term is a linear. It's linear because the power is 1 for x. So we have this one. So this tells you that x equals 0. If you set this one to be 0, so x equals 0, x equals 2i, and x equals negative 2i are zeros of this function f, right? Because if you plug in these 3 numbers, it will make this one to be 0. So now in this part, this theorem didn't tell you how to find this C1, C2, and 2Cn, right? So now I want to introduce some ways to find these zeros. Okay, so the first thing is we want to find the rational zeros, okay, which is called the rational test, rational zero test. It says if f of x equals an x to the n plus an minus 1 to the x to the n. This is the general form for a polynomial, right? a1x plus a0. This one has coefficient, integer coefficient, integer coefficients, then every rational zero has the form of rational zero can be written as P over Q, where P and Q has the only common factor only common factor 1. So that means you cannot simplify anymore. And P, what is P? P is a factor of A0, the constant coefficient. And Q is a factor of leading coefficient, AN. Okay. So the idea is we can use this rational zero test to locate all the possible rational zeros. Then we try each one to see if this one is 0 for the function. We just plug in this number into the function to see what happens. So now let's look at this one. We want to find this example, want to find this f of x equals x cubed plus x plus 1. Find the rational zeros. Of this function. So how to find? What is we need to locate the constant coefficient, which is A0, right? A0 equals 1. And AN is also 1. So P over Q, which is what? The top is the factor of A0, which is plus or minus 1, right? The factor is, we need to include the negative number, plus or minus 1. This is the factor. The factor of 1 for the Q is the factor of AN. AN has the factor plus or minus 1. So what is this? This is plus or minus 1. Plus or minus 1 divided by plus or minus 1 equals plus or minus, not equal to 1, okay? That means you can plus 1, positive 1 divided by negative 1. Negative 1 divided by positive 1. Negative 1 divided by negative 1. Positive 1 divided by positive 1. So there are 4 choices, right? So at last, you simplify, it would be 2 numbers. One is plus 1, the other one is negative 1. So then we just need to plug in to see what happens. Plug in 1. 1, so it's the 1 cubed plus 1 plus 1. So it's equal to 3. It's not equal to 0, so this is not 0. We plug in negative 1. So this is the negative 1 cubed plus negative 1 plus 1. It would be negative 1. It's not also not 0. So that means there is no rational zeros for this problem. No rational zeros for this problem. Okay. Let's look at another example. We still want to find the rational zeros for this function f of x equals 2x cubed plus 3x squared minus 8x plus 3. Okay. So our A0 equals 3. AN equals what? Equals 2, right? So our possible rational zeros is actually the factor. The top is the factor of A0, which is plus minus 1, plus minus 3, right? The denominator is the factor of AN, which is plus minus 1, plus minus 2. So it would be plus minus 1, or plus minus 3, or plus minus 1/2, or plus minus 3 over 2. So you have 8 choices, right? 8 choices. So we just try some, for example, we try 1, for example, okay? F of 1. F of 1 is equal to, it's the 2 times 1 cubed plus 3 times 1 squared minus 8 times 1 plus 3. So this is actually equal to 0. So that is great, right? The first one, it makes it to be 0. So we have this one. So do you remember we have the theorem says if this number is a 0, then x minus this number would be a factor of this function. So f of x can be written as x minus 1 times something, right? So now we want to know what is this part. What we should do? We just divide by x minus 1, right? We do the division. So we use the long division. Okay, so this is the 2x cubed plus 3x squared minus 8x plus 3 divided by x minus 1. So this would be 2x squared. So this is the 2x cubed minus 2x squared. So this is 5x squared minus 8x. So we have plus 5x. So this is the 5x squared minus 5x. So it would be negative 3x plus 3. So this is the negative 3. So negative 3x plus 3. This is equal to 0. Right? So our function f of x can be written as x minus 1 times what? Times 2x squared plus 5x minus 3. 2x squared plus 5x minus 3. So now, this term is a quadratic form, right? Of course, you can try to find the rational zeros first, right? You need to the factor of the negative 3 divided by the factors of the negative of 2, right? The negative 3 have the factor plus minus 1 plus minus 3. Then the 2 have the factor plus minus 1 plus minus 2. Then you take the division. Then you test, right? Continue using the same way. But the good thing is here is quadratic. Most time we can just do the observations to find the factorization. Otherwise, you can use the quadratic formula to find the zeros, right? So this would be x minus 1 times, so this is actually 2x minus 1 times x plus 3. Right? We can factorize this quadratic form directly. Okay, so far, we only consider the rational zero. So in other words, this is a rational, which is a rational number, right? So now, we want to look at the complex zeros. So before that, let's review that this is called a conjugate pair. Conjugate pairs, which is a plus bi and a minus bi. This is called a conjugate pair. Okay, so this theorem tells you that the complex zeros occur in conjugate pairs. What does this mean? This means, i.e., if a plus bi is a zero of f, then a minus bi which is also a 0 of f. So now let's look at this example. So we want to write f of x equals x to the fifth plus x cubed plus 2x squared minus 12x plus 8 as the product of linear factor. So in other words, we want to write this one as this form. This is called linear factorization, right? Okay, so the idea is still the same. The first thing we needed to locate. In other words, this is the find all zeros. If you can factorize it, you can find the zeros directly, right? So the first thing you still need to do is you need to find the rational zeros. Okay, so now let's look at this an equals 1, a0 equals 8. So our rational zero p over q is the top is what? The factor of a0 plus minus 1 plus minus 8, right? Plus minus 2 plus minus 4. So these are all the factors of 8. And the factor of 1 is plus or minus 1. So this one is plus minus 1, plus minus 8, plus minus 2, plus minus 4. So most time we will always start from some small number, right? So let's try 1 first, f of 1. F of 1 is 1 to the fifth plus 1/3 plus 2 times 1 squared minus 12 times 1 plus 8. So that is 0. That's good. So we find 1 directly, right? So we can write it as, so this function f of x can be written as x minus 1 times something, right? So we needed to locate this part. We use the long division. So this is the x to the fifth plus, we notice that there is missing term for the x to the fourth. As we talked in the long division, we needed to add this term. We'll add 0 times x to the fourth. Then plus x cubed plus 2x squared minus 12x plus 8. We divide by x minus 1. Okay. X minus 1. So we have, this is x to the 4. So x to the 4th. X to the 5th minus x to the 4th. So this is x to the 4th plus x cubed. So we plus x cubed. So this is x to the 4th minus x cubed. So this is the 2x cubed plus 2x squared. So it would be plus 2x squared. So this is the 2x cubed minus 2x squared. So this is the 4x squared minus 12x. So this is the plus 4x. So this is 4x squared minus 4x, right? So this is negative 8x plus 8. So it's negative 8. Okay, so this is negative 8 plus 8 equals 0. So that means f of x can be written as x minus 1 times x to the fourth x to the fourth plus x cubed plus 2x squared plus 4x minus 8, right? So we want to, so you can see so the next task is to factorize this part, right? So actually this one is much easier than the previous one. The reason is here the power is 4. The original one power is 5. So we're actually using this way, we decreased the power. And we also know these are all the possible rational numbers, right? All the possible rational numbers. Yeah, we're using the same way for this one, right? For this one, the possible rational number is what? Let's look at, for this part, we consider g of x is equal to x to the fourth plus x cubed plus 2x squared plus 4x minus 8, right? So the possible rational, which is the coefficient for the constant here, this is the plus minus 1, plus minus 2, plus minus 3, 4, sorry, plus minus 8, right? This is the 1, so it's the plus minus 1. So this is the plus minus 1, plus minus 2, plus minus 4, plus minus 8. So now let's try f of 1 again. F of 1, so it's 1 to the fourth plus 1 cubed plus 2 times 1 squared plus 4 times 1 minus 8. Again, this is 0. So x minus 1, oh sorry, not g, not f, we should have g here. Right? Okay, so this tells you that x minus 1 is this factor of this part. So our gx can be written as x minus 1 times something, right? So we want to find it, so let's look at, we'll divide this gx, which is x to the fourth plus x cubed plus 2x squared plus 4x minus 8 divided by x minus 1. So you will have x cubed, x to the fourth minus x cubed. So this is the 2x cubed plus 2x squared plus 2x squared. So this is 2x cubed minus 2x squared. So this is 4x squared plus 4x. So it's plus 4x. So this is the 4x squared minus 4x. So it becomes 8x minus 8. So this is 8 plus 8. So this is the 8x minus 8, which is equal to 0. So in other words, our gx is equal to x minus 1 times x cubed plus 2x squared plus 4x plus 8. Right? Then let's consider this part. Let's consider this part. So this is the f of, we'll use another letter. So let's consider this h of x, which is equal to x cubed plus 2x squared plus 4x plus 8. So again, the possible rational number, rational zero is, here is the positive 8, so it's plus minus 1, plus minus 2, plus minus 4, plus minus 8. Here is plus minus 1, right? Because here is 1, right? The coefficient is 1, so the factor is plus minus 1. So again, this is plus minus 1, plus minus 2, plus minus 4, and plus minus 8. So if you try 1, everything is possible, right? Every term is positive, so h1 is not equal to 0, obviously. Let's look at h negative 1. h negative 1 is negative 1 cubed plus 2 times negative 1 square plus 4 times negative 1 plus 8. No, it's not 0. So h2. This time we are not lucky, right? We tried 2 numbers, they are not zeros. So let's try the third one. 2. So it's the 2 cubed plus 2 times 2 square plus 2 times 2 plus 8. Every term is positive, so it's not equal to 0 again. Let's try h negative 2. So this is negative 2 cubed plus 2 times negative 2 square plus 2 times negative 2 then plus 8. So let's calculate. So this is negative 4. This is negative 8. So it becomes negative 12. This is 2, 4. Sorry, I made a mistake. So here it should be 4x. Right, here is 4x. So this is 4x. So this is 4 here. So this one is equal to 0, right? This one is equal to 0. So our h of x can be written as x plus, because it's negative 2, so minus negative plus negative plus 2 times something, right? So we just we want to find this part. So hx is x cubed plus x2x squared plus 4x plus 8 divided by x plus 2. So this is the x squared, x cubed plus 2x squared, 0, right? So we need 2 terms. So we move down 2 terms, plus 8. Okay, so we have, we should have, so this is 0 plus 4x. Then plus 0. We make this one to be 0, right? It's 0 plus 0. So this would be 4x plus 8. So it's plus 4. So this is the 4x plus 8 equals 0. Okay, so our h of x can be written as x plus 2 times x squared plus 4. Okay, so you can see we reduce the order to x squared. X squared plus 4, we are familiar with, we can factorize it in the complex number system, right? This is the x plus 2 times x plus 2i and x minus 2i. So now let's summarize it. Our original function f of x, which is equal to, let's just write down the original function. which is equal to x to the fifth plus x cubed plus 2x squared minus 12x plus 8. So now we actually factorize it, right? This is a very complicated one. It's equal to the first one, we test the x. This one, f of x, can be written as x minus 1, right, times this g. So we must have x minus 1. Our g can be written as x minus 1 times this one, right? So it's x minus 1 again, times h. H can be written as this part, this h. This part can be written as this one, right? So it's x minus plus 2, x plus 2i times x minus 2i. So this is a linear factorization, right? So our zeros are x equals 1, x equals negative 2, x equals negative 2i, x equals positive 2i, right? So we notice that this x equals 1, the 0, the multiplicity of 0 is 2, right? So you actually can write this is x minus 1 squared, that's x plus 2, and x plus 2i, and x plus minus 2i. Okay. So if we just want to sketch the graph, to remember how to sketch the graph of the polynomial, right? We don't need to factorize this part. We just need to factorize the real zeros, right? Find the zeros, then find the behavior and the behavior, then draw the graph, right? At x equals 1, because the multiplicity is 2, so we touch the point at x equals 1. And x equals negative 1, negative 2, because the multiplicity is 1, so we just cross this point, right?